Hello there. Welcome to this video. This is 9-1 and we are talking graphing trigonometric functions. What we're going to do is go ahead and review how we graph trig functions and basically the parent functions, and we'll look at a couple of cases where we have to apply some transformations. All right. So where I want to go ahead and start out is with the parent functions. So just some reminders that trig functions are periodic, meaning that they kind of cycle through, right? They repeat after a certain point, and that's called their period, right? Until they start repeating. Sine, cosine, their reciprocals, cosecant and secant, all have periods of 2 pi, while tangent and cotangent have periods of pi. Okay, and it's pretty easy to graph these. The parent functions based upon like our knowledge of the unit circle and our previous knowledge, right, from Accelerated Math 3 or pre-calculus, whatever you had. If you want more kind of experience or more, I don't know, more like I have videos for Accelerated Math 3 on my website, Unit 14, Graphing Trigonometric Functions, so you can go ahead and check those out there. All right, let's go ahead. Let's check out these parent functions. We'll start out with sine and cosine of x. And let me switch up my colors. Okay, so sine of x. Sine of x, they have a period of 2 pi, and it starts at the origin, right? And if you ever forget to, like, where does sine of x start, always think about the unit circle. What's the sine value at 0? It's the y value, 0, okay? So, and then also, too, that the graph is divided into fours, okay? So, here, I'm going to split this into fourths, and my function will have another intercept at pi, and it increases, right? So from here, it's going to go up, okay, and then down to its minimum, right? So this is sine of x, right? And its amplitude, like how high, right? The distance from the midline, the middle, to the max or to the min is 1 for all the parent functions. And I can continue this kind of process, right, for another period or another cycle. So you get this kind of graph. All right, there is sine of x. Cosine of x, same kind of principle. Cosine of x has a period of 2 pi, but it starts at a maximum of 1. And again, where does cosine start? Well, what's cosine of 0? Oh, it's the x value, 1, right? So it has a period of 2 pi, which means it will repeat, okay? And then halfway in between is going to be its minimum, right? And then again, in between will be x-intercepts. So it looks like this, okay? So, and I can continue again, right? So max, intercept, min, intercept, max. So this is the cosine of x function, okay? All right, very, very easy. What I'm going to do now is go ahead and graph cosecant of x and secant of x. And these, right, are the reciprocals of them. So 1 over them, right? So cosecant of x, this is 1 over sine of x. And so where sine of x is 0, trying to switch colors, here and here and here, what you're going to get for cosecant of x are some asymptotes. So I'll have vertical asymptotes here. I'll have one here at pi, right? 1 at 2 pi, and I can go the negative direction, negative pi, and negative 2 pi. And again, that is because, right, I have a denominator 0 there, so it's undefined. And cosecant of x, right, at my maximums or my minimums, I'm going to have a slope of 0, right? So anyway, I have a point here and a point there. Okay, and it just looks like a parabola. Plain and simple, right? And here, for this point, it is below the x-axis, so my parabola is below the x-axis there. Okay, so it kind of just mirrors the sine function, which makes sense because it's reciprocal, right? And then one up here. Plain and simple, right? So mins and maxes at 1, just like the sine function. All right. Okay, now let's go ahead and talk about secant function. So same idea. Again, where does it cross the x-axis? Here, here, here. Okay, so there's going to be asymptotes at all of those locations. So asymptote here at negative 3 pi halves, asymptote here at negative pi halves, 1 at pi halves, and at 3 pi halves. Okay, so there's my asymptotes, and again, I'm going to use the same idea. So wherever there's a max for a cosine function, I'm going to have 1, but it'll be a minimum, right, of my parabola. Okay, and this one's down here, and there is secant of x. Pretty easy, right? Okay. And last but not least. Okay. So there's our functions with a period of 2 pi. Now, tangent and cotangent have a period of pi. And tangent, I'm going to go ahead and rewrite this. Tangent is sine over cosine. Okay, so where is cosine going to have, where's cosine of x going to be 0 is what I'm saying. Well, that's at the north and the south pole of the unit circle, right? Pi over 2 and 3 pi over 2. So we have an asymptote here, an asymptote at, well, and if we're going the negative direction, negative pi over 2. Okay, so there's our asymptote, and it models the, I'll switch my colors here. What color? So many choices. Let's go purple. It models the cubic function. So it looks like this. Okay. And over here, it will look like this. Okay, so there is our tangent function. All right, and now we're going to go ahead and graph the cotangent function. So cotangent is the reciprocal of tangent. So we have cosine over sine. So it makes sense whenever sine of x is 0, like at 0, right, we're going to have an asymptote, or at pi, or negative pi. Okay, and it looks just like the tangent function, except it's decreasing rather than increasing. Okay, so our intercept will be here and here. And these are our other points, which are kind of optional. It just know that, right, it looks very similar to the cubic function. Okay, and there is cotangent. All right. Okay, and if you want, and if you want, right? Okay. So all of those graphs are very important. The most important being sine and cosine. Make sure you memorize those and where they kind of start. And again, like I said, if you utilize your knowledge of the unit circle, it should be very, very easy. But like all of our graphs, what we're going to have to do is be able to graph transformations of these. Okay, so here is the general form: y equals a sine of b times x minus c plus d, where all of these are transformations, right? So let's look at these transformations. Again, our a value, right, our multiplier out front, this is going to be our amplitude, right? And if you're familiar with kind of graphing with transformations, this controls stretch and compression. So that controls the min and the max of our functions. Our b value, this is a horizontal stretch or compression, which we call period change, right? And what we're going to end up doing is just dividing whatever that value is by 2 pi, and that will be our new period. Now, we also do have left and right shifts, up and down shifts. The ones that go left and right, we call these phase shifts, and a phase shift is by your c value. Okay, so that will take you left or right, and you have to make sure you factor out your b value, and we'll see that in an example. And then again, our d value out here, this will take us up and down. Make a note if you're in my classes and you have these notes. Notice how our c value, from what you're used to seeing a negative in front of the c. Your notes have it different, and I couldn't change it in your notes. I apologize, but you guys have pluses, just make note of it, right? Okay, let's go ahead and look at an example. And here we have an example for f of x equals -5 cosine x over 2. So what we want to go ahead and do is, I'm just going to make note of the amplitude. The amplitude is the absolute value of a, which is 5. So that just means that my mins and my maxes are going to be 5 from the midline, and also 2, I mean, we have a negative, right? So that's going to cause our graphs to flip, okay? So just make note of that. Also, too, what we have is we have a b value, which is 1/2, right? So our period is going to be 2 pi over the absolute value of b, right? Which in this case is 1/2. So 2 pi over 1/2, which is 4 pi. Okay? All right. So knowing about cosine, okay, so cosine normally starts at a maximum of 1, right? So in this case, our maximum would be 5, but it's negative, so we have to flip. Okay, so I have a starting point here, and every 4 pi, right, that's our period, it's going to repeat, okay, at negative 5, okay? And then in between, right, we're going to have a max. So up here, and then up here, okay, and in between that, we have our intercepts. Okay, so you can just think about dividing your graph into 4s, right? So 1, here's the middle, and then middle. Okay, so you get your graph, which looks like this. And there you have it. There is that example. All right, part B, we have sine of 2t minus pi over 2. And in this case, this is what I'm talking about, is that b value that is kind of hiding. So we have a phase shift, or a b value of 2. I'm going to factor it out, and we get t minus pi over 4. Okay, so again, in this case, our amplitude is 1. Our period is 2 pi divided by the absolute value of b, which in this case is 2. So we'll have a period of pi. And then we also have a phase shift, meaning we go left, right, of pi fourths, positive pi fourths. So we're going to the right pi fourths. Okay, so sine function. Remember, sine starts at 0, 0. So I'll go ahead, start at 0, 0. But we have a phase shift pi fourths going right. Okay, and our period is pi. So every pi, I'm going to repeat. Okay, so 1, 2, 3, 4. And there you have it. Okay. In between, we'll also have another intercept, right? It's kind of broken into fourths. When I keep talking about the fourths, this is what I'm talking about, right? Like here's 1, splitting it into fourths, right? So 1, 2, 3, 4. Okay, so I'm going to go up, down, down, and then back up, right? So here is our graph. All right, and I can repeat this. So down, intercept, max, intercept, min, intercept, max. So that one's a little, that was really low. Okay, and here is your graph. All right, very, very straightforward. Okay. All right, last but not least, we're going to go ahead and talk about Pythagorean identities. Now, the main identity that you need to know, the Pythagorean identity, is sine squared plus cosine squared is equal to 1. And what you'll also see are some adjustments off of this. So if I just wanted to go ahead and I want to isolate, say, sine squared theta, right? I wanted sine squared theta by itself, so I have to undo or remove cosine squared. So these are some identities that you'll need to remember. And then the other one, what if I wanted cosine squared isolated? Well, that is 1 minus sine squared theta. These are the most important ones and the ones that you'll see over and over and over again. Okay, so example 5, it says use Pythagorean identity to rewrite 2 cosine theta minus sine squared theta equals -2 in a form that only contains one trig function. Then, without using a calculator, solve for theta on the interval 0 to 2 pi. Okay, so I'm going to go ahead, I'm going to take 2 cosine theta minus sine squared theta, but instead of sine squared theta, I'm going to use my identity. I'm going to replace it with 1 minus cosine squared theta. And I'm going to go ahead and solve this. So after I distribute a negative, I get positive cosine squared theta plus 2 cosine theta minus 1 is equal to -2. I'll add 2 to both sides. Add 2, add 2, that gives me +1. Okay, and then I can go ahead and factor this. So this is cosine of theta. That's going to be +1 times cosine of theta +1. So cosine theta +1 squared, if you will. And if I solve, we get cosine theta +1 is equal to 0, which means that cosine of theta is equal to -1. And that only occurs at one location in our unit circle, which is pi. I almost wrote -pi. I don't know why. All right, there you have it. Okay. All right, so in this video, we went ahead and we graphed some trig functions. Very, very important to know sine, cosine. Again, if you need to go back to my Accelerated Math 3 videos, go ahead and do that. And then we looked at solving some trig equations with trig identities. Catch you next time. Peace.